Hello, welcome to another video. This is Lyndon again, and today I want to test the validity of the measurements scientists give us. Alright, so I guess it's not just scientists, anybody who believes in a round world, and they study this with mathematics and try to figure out the size of the moon, size of the earth, distance. They come out with these measurements, so we're going to test it. I mean, a lot of people, they don't know the mathematics. They can't do the studies to figure out these things themselves. But what we can test to see if what they have, or what other people have given us to be true. So here it says the size of the moon is 1,079 miles. Size of the earth is about 4,000, which is 3,959 miles. And the distance from the earth to the moon is 238,900 miles. All right. So basically, I created Basically, I created a 3D simulation of this here, and here's the Earth, here's the Moon, and I made this based on these measurements. All right. So I made the size of the Earth, size of the Moon, the Earth distance completely right according to those measurements. And if we have a look here, there's just another simulation I found on Google Images, where it comes out with a very similar result. I guess I can kind of flip this around. I don't want to go too long about this. Zoom in a little bit. There we go. Alright, so here's the Google Images, and it kind of comes out with a similar result about the distances and everything. I just scale it up a little bit. So yeah, so it seems to be pretty consistent. What I created here is exactly right according to these measurements. So let's go ahead and start testing out the validity. So here we go. I made the sun. You can see this. Well, let's see. I made the sun very far away, so it's like extremely far away. So basically, the Earth is between the moon and the sun. So the Earth is right here, and it's between the sun and the moon. All right. So basically, what should be created here is a lunar eclipse according to the globe Earth model. So a lunar eclipse should be created here. So let's go ahead and take a view here. I want to show you the view. Here's the Earth and here's the moon. If we go ahead and render this out, we see a shadow from the Earth is being casted onto the moon. All right. So I'm trying to simulate, what scientists say the Earth is. They say it's a sphere and the moon's over there. So I'm trying to simulate some scientific situations to see if it's valid. So I'm going to go ahead and get a view of the moon here. I'm going to render this out to cast it to render the shadows. Alright, so I got it. And we can see that this is the Earth, the shadow of that sphere over here. This Earth right here, or the round view of the Earth. This is the Earth, and it's casting a shadow onto the moon. So based on the measurements and what scientists give us, these measurements, this is what a lunar eclipse should look like. Alright, because we made all the measurements according to what the scientists say and everything. So this is what a lunar eclipse should look like. So we make a prediction. This is what a lunar eclipse should look like, and we're testing to see if what scientists give us is true. Well, interestingly enough, if you look at a real lunar eclipse, a very similar result comes out. So I find it a bit hard to say that, to deny how consistent the measurement scientists give us. So if you look at the lunar eclipse here, I just simulated it from these 3D models and everything. It's very similar to a real lunar eclipse. I mean, this is a real picture. I mean, I don't think anyone would deny that this is a real picture of a lunar eclipse. I mean, I've seen a lunar eclipse myself, and I'm sure anybody over the age of 12 has seen several lunar eclipses and remembers them, unless it was cloudy or whatever. Okay, but I've seen a lunar eclipse myself, and this is what they are. This is what they look like, and this is a real picture of a lunar eclipse. So, and it's so similar to what I've created here that I can't help but it's the measurements the scientists give us are consistent, because what I simulate here is exactly what we see in real life. So I guess this isn't proof against the flat Earth, but it does really show that the measurements that scientists give us are consistent to what we see in real life. So I don't know what your opinion is on this, but I hope you'll be open-minded and understand what I'm saying here. So I guess that's all I have to say. You guys have a good day.